This horrific story is unfortunate and too common in pools equipped with dangerous direct suction main drain systems. The U.S. Consumer Product Safety Commission produced a report in 2011. In it, a circulation entrapment is defined by the CPSC as an entrapment involving the water circulation of a product. From 1999 through 2010, the CPSC staff is aware of 97 reports of circulation entrapments. The most glaring statistic of these findings is the number of children injured or killed in these incidents. Sometimes this happens in front of their horrified parents, who try unsuccessfully to free their child, but the hold-down force of the pump is too great, and they can only be freed when the pump is shut off. Many times the pump is located quite a distance away and usually in a locked equipment room. Suction entrapment can happen when a body is pulled onto a suction port or main drain. Generally speaking, it happens when a person comes in contact with such a port and part of their body, clothing, hair, or jewelry is held down, entrapped, or entangled by a force created by the pump. The suction power produced by this force can be staggering. Direct suction in the swimming pool industry can be defined as a recirculation system where the suction side of a centrifugal swimming pool pump is connected by a pipe to the main drain or other submerged port in the pool or other body of water. When the pump is turned on, it draws water directly from the drain. Virginia was the granddaughter of former Secretary of State James Baker III, and as a result of this incident, powerful forces were set in motion to prevent this from happening again. On December 19, 2007, the Virginia Graham-Baker Act became law. This rule requires every swimming pool or spa drain cover manufactured, distributed, or entered into commerce in the United States to conform to the ASME ANSI A112.19.8 performance standard. These drains are specifically designed to prevent suction entrapment. In suction entrapments documented on swimming facilities around the country, almost every case reports that the grate was missing or broken. There are instances during original construction of a pool where the holes that were provided for screwing down the grates to the frame are accidentally filled in with concrete during the pool finishing process. This may prevent grates from being attached properly according to the manufacturer's requirements. For these and other reasons, the VGB law requires a second layer of protection. Those approved options are an SVRS or Safety Vacuum Release System. It must be tested by a third party and found to conform to the ASME or ASTM standard. Suction limiting vent system with a tamper-resistant opening. Gravity drainage system that utilizes a collector tank. Automatic pump shutoff system. Drain disablement system. Any other system determined by the Commission to be equally as effective as or better than the previously described systems. The United Pool and Spa Association, or UPSA, decided to secure the help of a credible source to test and record the operational forces created by a direct suction system. Dr. James Fletcher with the University of North Florida's Science and Engineering Department in Jacksonville was retained to complete this endeavor. A test pool was designed and constructed in Jacksonville by Vak Pak Incorporated to simulate the hydraulic forces created by direct suction circulation in a pool. This testing was completed in August of 2012, and a copy of the report can be obtained from the United Pool and Spa Association. The university recorded the hold-down forces in pounds and the time it took to create those forces. The first series of tests were intended to simulate and document a body sealing a 12-inch drain where the grate is missing on a direct suction system. The results were dramatic, to say the least. Using a standard 2-horsepower centrifugal swimming pool pump connected to a suction port on the drain, and then covering the drain with the 24-inch aluminum test apparatus, over 1,500 pounds of force was reached within 3 seconds when the pump was turned on. In a subsequent test using a 16 by 16 test plate with a 1/2-inch thick rubber mat, over 1,800 pounds was reached instantly when the drain was covered with the seal while the pump was already running. During this test, the seal plate was sucked into the drain and could not be removed until the pump was powered off. This confirms reports from past tragedies not unlike that of Virginia Graham Baker. Recognizing the danger posed by direct suction outlets in swimming pools and spas, the Florida State Department of Health requires gravity flow recirculation systems using a collector tank on pools since 1977 and on spas since 1993. Of the approximate 31,000 pools in Florida with gravity systems, there have been no entrapment injuries or deaths recorded. Of the approximate 6,000 pools and spas with direct suction systems, there have been 6 documented deaths. Statistically speaking, the state of Florida has saved about 31 lives by enforcing the use of gravity flow systems. Florida is the only state to mandate this form of protection. A gravity drainage system works on the principle that a properly sized and located collector tank installed between the pool or spa and the pump can limit the amount of force created when the main drain is blocked. The suction line from the pump is connected to the collector tank, not the main drain. When the pump is turned on, water flows from the main drain in the pool to the collector tank by gravity, and from the collector tank to the pump by pump-created suction. With this type system, the main drain is not a source of suction from a pump. Because of Florida's perfect record of no suction entrapments recorded on gravity flow systems using collector tanks, an ASTM standard for collector tanks is being written. To help answer some of the questions posed by the committee developing this standard testing on gravity flow systems, the University of North Florida conducted similar tests using the same equipment that was used for the direct suction testing. A striking difference was discovered. A similar 12-inch drain sump was covered with the same device by university staff. The drain had a port connected to a collector tank. The 2-horsepower pump drew water from the collector instead of directly from the drain. When the pump was turned on, it took over 60 seconds for the force created to reach 183 pounds, or approximately 0.8 pounds per square inch. Even though there was a dramatic reduction of force using a collector tank, there was not enough evidence to prove conclusively that a person could not be trapped. It was determined that a live test using a human subject would be performed to give conclusive evidence. The test subject is a 240-pound, 6-foot-tall certified diver. Several attempts were made to seal the drain with the VGB-compliant cover in place with no success. The cover was removed and the subject was able to seal the opening of the drain with the help of a gasket. The subject was required to employ the use of a weight belt to help hold him down during the testing to allow time for his body to seal the drain. As the water level in the collector tank receded due to the interruption of water flow from the pool, the subject noted a slight pull from the drain. When the water level in the collector tank reached the suction port 30 inches below static pool water level, the subject easily rolled off the drain. This test emphasizes the eccentricity or flexibility of the human body and how it is able to move from the drain without battling the effects of the total forces created. A test was conducted on the same drain utilizing a seal similar to the one used on the University of North Florida's testing. When the seal was made and the water in the collector tank reached the lowest level, the subject tried to lift the plate off the drain from a handle device located in the center of the plate. By lifting straight up, a weight similar to the UNF test report of 183 pounds was experienced. However, when the test subject, using his thumb and forefinger, lifted the corner of the sealed plate under the same pressure, no resistance was experienced and the plate was easily removed from the drain. This is consistent with the eccentricity of the human body. It was determined that even though the 183-pound hold-down force seems too great, it was based on the large area of the drain opening. It actually only results in approximately 0.8 pounds of hold-down force per square inch. In comparison, the University of North Florida's testing revealed a significant difference in the created forces of direct suction and gravity flow. Statistics from the United States Consumer Product Safety Commission verifies how deadly direct suction forces can be, while a 35-year history in Florida with no documented entrapments confirms the safety of collector tank use. In conclusion, the state of Florida apparently made a great decision in 1977 when it mandated gravity flow as a prevention to suction entrapment. Since most of the other approved forms of secondary protection have the potential for failure due to potential power interruption, ease of displacement, or their need for constant monitoring and/or calibration, the 18 engineers at the Florida Department of Health refused to sign off on their use. Because a collector tank requires no power and has no moving parts, there is no calibration or ongoing testing required ensuring proper operation. Because of its design, it is very difficult to disable. We would like to thank Vak Pak Incorporated for providing and facilitating this testing. If you have any questions or concerns regarding main drain suction entrapment or the use of gravity flow collector tanks, call Vak Pak Incorporated at 1-800-877-1824 or www.vacpak.com.